Hi, I'll go over how to perform lab 2 of ECE 285, which is 286, which is steady state RLC. So for lab 1, you have a RCL series circuit where you're varying the frequencies from 1K to 15K and a 6K in the middle of that. And then you just want to measure the voltage drop across the supply and then the combination of voltage drop across the inductor and resistor. So those two elements. So here's my circuit. So this little circular looking device is my inductor. This is my capacitor. And so I have my channel 1 connected across my supply. And my supply is coming from that green cable, and then my ground is the black cable. And then channel 2 is measuring that combination of voltage drop across that resistor and inductor. And for this experiment, I replaced my resistor with a 3K resistor, and my capacitance and inductance is the same as as instructed in the lab manual. And I'm just going to measure the voltage drop at specifically 6K. So let me open up Scopy and then clear all this. So I will send in my signal of 5 volts peak, 5 volts amplitude, 5 volts peak. So which is 5 volts peak, which is 10 volts peak to peak. And then I will send in at 6K. There we go. And then I'll go ahead and run that. And then I will click single, and there we go. That's my data. So let's see. Let me just increase this and increase my vertical and then decrease my time base. And then let me click single again. There we go. That looks prettier. That looks like sine waves. And when I do that and disable my cursor, you can measure the voltage as about the same. Okay. And then for the second part, you have this funky looking circuit and you are adding a resistor in 2 branches with a resistor, with a capacitor and an inductor. And then you're measuring the voltage drop across these resistors. So what you want to do is evaluate the circuit at 3 different frequencies and measure the voltage drop of the resistor in the capacitive branch and the voltage drop across the inductive branch. And then you want to measure how the phase and voltage change, which you can easily do by a frequency sweep. I believe there's a section that says, yeah, there was also a frequency sweep mentioned in the previous section. It just depends on if your TA wants that or not. Same with this. If you don't know, it's safe to do, just do the frequency sweep, which is, come on, it's going under Scopy, going under Network Analyzer, and Network Analyzer, not Spectrum. And then let me just remove this reference and then just click single. And let me stop that really quickly. So my channel 1 is across the supply, so it has to be referencing channel 1. So reference channel 1, and then I'm going to do amplitude of 5 volts. Then go and click single. And so this would be my frequency sweep for experiment 1, which I didn't include. And it'll go ahead and run. But for experiment 2, you're measuring at 3 different frequencies, and then you also have this measuring the frequency sweep essentially. So I'll just go ahead and do it at 6K, like again. Let me switch this over to Scopy. So that would be the frequency sweep for experiment 1. Signal generator. Okay. It's off. Cool. So now I'm going to rewire my whole circuit. So give me 1 moment. Okay. So my circuit's pretty tight, but let me see if I could zoom it in a tiny bit more. Okay. So this is my circuit. So this section over here is my inductor in series with the resistor. On the right, it's my capacitor in series with that resistor, and then the final resistor, which is the power supply branch. And then channel 1 is measuring that voltage drop across. Okay, channel 1 is measuring the voltage drop across that resistor in that inductive branch. Channel 2 is measuring the resistor in the capacitive branch. Okay, so now let me switch over to Scopy. Go ahead and send that 5-volt supply at 6K, and then go to my oscilloscope and go and click single. And then here you go. So this is what the waveform looks like. You can switch that scale because it's a smaller waveform. And then you have the voltage drops at the top. If you enable your measure right there, you'll get the voltage drop. So you can see there's a slight difference in the voltage, but as you change the frequency, you will see a noticeable difference in the voltages. And that's essentially how you do experiment 2. For experiment 3, it's essentially the same thing, but now you're adding in other elements. So for the first part, you're adding an additional 10K resistor in series with the original resistors. So in the capacitive branch, you will have a resistance of 10.1K in series with that capacitor. And then the inductive branch, you'll have the inductor with still 100 ohm and then still 100 ohm here. And then you measure the voltage, the magnitude, and then the phase shifts relative to the power supply branch. And the way you would measure the phase shift is, I'll just use the data from my second experiment. What I could do is just make it smaller so it's easier to see the peak, the time base that is. Go ahead and enable my cursor, go to that little 2 parallel bars, make sure it's track. There we go. Now I can see it. And then just get it to the peaks or the mins of both waveforms, and then use that change in time, which is about 19.2 microseconds. And multiply that by 2 pi divided by the period. And that will give you the relative phase shift. Assuming that one of this was the power supply. So from the data that I collected from experiment 2, this is the inductive resistance and the capacitor in resistance. So you can't really necessarily measure the phase shift between both of these, but you would have to add in your power supply waveform. So maybe you might have to do it separately. So you do a power supply and then just the resistor resistance across the inductive branch, and then do another measurement where it's the power supply and the resistance across the capacitor branch. And then that's just part 1. So part 2 of experiment 3 is essentially experiment 2. So you don't necessarily have to do that. But then part 3 is where you remove that extra 10K resistor from this capacitor branch. So now you will only have 100 ohms in the capacitive branch, and then you'll add that 10K into this inductive branch. So now you will have 10.1K resistance in your inductive branch while you still only have 100. So, and then you measure the voltage and then the relative phase shifts. And that's essentially how you do experiment 2, lab 2 for ECE 285.